So, hey guys, welcome to the solution video of today's Div 4 round. Let's start with problem A. So, what does problem A say, right? You are given a string of length 5 whose characters are either A or B. You have to print which character appears most frequently. Is it A or is it B? So, first thing to notice is that, right? Since you are given a string of length 5, it will never be that frequency of A is equal to frequency of B. This is never going to happen since this is odd, right? Because if this was true, then this would have been an even number. So either frequency of A is greater or frequency of B. So our solution is very, very simple. You run a for loop and count the frequency of each number. Count frequency of each number. Okay. And in the end, which has a greater frequency, let's say if A has a greater frequency, then you print A, otherwise you print B. Any doubts in this question, guys? Does XOR work here? I mean, why would you want XOR to work here? I don't think it should, because there can be a case where A comes odd number of times and still it's the most frequent, and there's also a case where A comes even number of times and still it's the most frequent. So you don't really, it's the same time complexity, right? So doesn't really matter. So the solution is quite simple. You take in a string and you need to count the frequency. So you iterate through every character and then you count the frequency of A, frequency of B. What I'm doing here is that there is a variable I, and if that I is A, then A gets incremented. If that character is B, then B gets incremented. If frequency of A is greater than B, then we print A, otherwise we print B. We just need to calculate the frequency. It's a very, very simple problem. Is there any doubts in this problem, guys? What about others? Okay. So moving on to problem B. Problem B, I solved in a very unique way. I think some people might have also solved it like this, right? So Vladislav has a binary square of n into n cells. A triangle or a square is drawn on the grid with symbols 1, and he's too busy being cool. He asks you to tell him which shape is drawn on the grid. A triangle is a shape consisting of k consecutive rows, where the ith row has 2 into I minus consecutive characters, so on and so forth. So, and there is a square. Okay. So, what is the basic problem is that you are given an n into n grid. Okay. And it is confirmed. Okay. It is very important to know. It is confirmed. Okay. That either this grid is going to have a square, okay, or this grid is going to have a triangle. Okay. This is the problem statement. Now, what is a triangle? A triangle is something like this. And what is a square? A square is a shape something like this. Is the problem statement clear, guys? Just give me a second. Okay. I hope my screen is visible again. Okay. I hope my screen is visible again, guys. Yes. Okay. So getting back to the problem, right? That either the grid contains a square, otherwise it contains a triangle. So as I was saying, is the problem statement clear? Yes. Now, since the problem statement is clear, let's look at a very ingenious observation. If we look at the grid when we have a square, and if we look at the grid when we have a triangle, let's see what is different. Okay. It doesn't really matter how much squares are there, right? It's either going to be whatever. So when it is a square, you can see that the grid is something like this, and the rest are zeros, if I'm not wrong. Yeah, and the rest are zeros. But when there is a triangle, it is something like this. Okay. And I hope this is the case. So the thing to notice is that when we have a square, all the rows where there is a 1, there is at least 1. Okay. 1. So this row has a 1, this row has a 1. The frequency of ones in both of these rows are the same. And in this one, the frequency of ones in all the rows are different. Basically, what I'm trying to say is, for confirmed, we are given if it's a square or it's a triangle. And there is only going to be one shape. Now, if it is a square, all the rows that contain a 1 are going to have the same number of ones, right? So all that we need to check is all that we need to check is count number of ones in each row. Okay. Now, if this number, basically, if the number of ones in that row is greater than 0, basically there is at least one present in that row, you put it in a set. And in the end, what do you need to check? If s dot size is equal to 1, then it's a square. Otherwise, it's a triangle. This is all that you needed to do to solve the problem. Is there any doubt in this? It's a very simple observation that it is confirmed that we are given a square or a triangle. As you can see here, if it's a square, okay, we know there is going to be only one square. So all the rows that have a 1, you can see this row, this row, this row, this row, they're going to have the same number of ones. This row has 4 ones, this row also has 4 ones, this row also has 4 ones, this row also has 4 ones. So I just iterate through every row and count the number of ones. If the number of ones is same in each row where there is at least a single one, then we print that it's a square. Otherwise, if it is different, then we can be sure that it's a triangle. Does this solution make sense to you guys? Tell me. Put a yes in the chat if you understand. If you don't understand, please let me know what are you not able to understand. I know it's a kind of a offbeat type of solution, but it's a very simple observation. Like you don't need to check if it's a square or anything. You don't need to run lots of while loops. All you need to do is check the frequency. So basically, I have a set called sizes. I have string s, cn s, and the number of ones is stored in the variable called sz. Now I iterate through that particular row, and if that character in that row is 1, I increment my counter. Basically, what I'm doing is I'm iterating through every row and counting the number of ones. The number of ones is stored in the integer size or sz. Now, if sz is greater than 0, it means that this row contains at least a single one. Then I insert it into my set. If the size of the set is not equal to 1, then it's a triangle, otherwise it's a square. What about others, guys? Tell me. For all the people who are in the meeting right now, were you able to understand this solution? Yes? Great. So we have tackled A, we have tackled B. Now moving on to C. Okay. Now what is C? Vlad and a sum of digits. Vladislav wrote the integers from 1 to n inclusive on the board. He replaced each integer by the sum of its digits. What is the sum of boards? What is the sum on the number of boards from now? Okay. For example, if I have the numbers 1 to 12, then this number, then 10 gets converted to 1 because sum of digits is 1. If it's 11, then 11 gets converted to 2, 12 gets converted to 3, so on and so forth. Now we just need to print till n. If we convert all digits to its sum of digits, then what is the answer? Okay. So guys, this is more or less useless. I don't think anyone got, whoever wrote a simple intended solution did get a TLE. Okay. Now, what is the idea over here? First of all, what does the problem statement say? You are given a few test cases, and for each test case, you are given an integer n. It is important to notice that this n is smaller than equal to 2e5. Okay. This is very, very important. Why is this important? Because let's say if we pre-compute answer for every n from 1 to 2e5, it would at most take us around 2e5 operations. And this will fit inside our time limit. So this n smaller than equal to 2e5 does play an important role. So what is the solution here? Our solution is that first we have to write a function that calculates the sum of digits of a number. Sum of digits of a number. Okay. After that, what is our idea? We are going to store an array. Let's name it f. Okay. In this array, what are we going to store? F of I denotes the answer when n is equal to I. Okay. Basically, for every n, we are storing that value in f of n. So f of 1 will store the answer when n is equal to 1. F of 2 will store the answer when n is equal to 2, so on and so forth. And a simple thing to notice is that, let's say I have n is equal to 4 and I have n is equal to 5. Okay. A simple thing to notice is that if I have the answer of this, okay, let's say its answer was x, then the answer for if for n is equal to 4, answer is x, then for n is equal to 5, basically for n plus 1, if n was 4, then n plus 1 is 5. Then for n plus 1, the answer is just answer of this, which is x, plus sum of digits of this number, which is 5. Does this much make sense, guys? Tell me. Put a yes in the chat if you understand till now. What have we discussed? N smaller than equal to 2e5 matters because we are going to pre-compute every answer. And apart from that, what is the idea? What is the basic observation? Is that for an n, if we have an answer, then for n plus 1, the answer is just the previous answer plus the sum of digits for that particular value. So if we know this, what can we basically do? We can just run a for loop from I is equal to 0 to 2e5. And then how do we pre-compute? F of I is nothing but f of I minus 1. As we discussed, if you want to calculate an answer for a particular value n, we'll just take the answer of n minus 1 and we will add sum of digits of I to it. And then what will we do? We'll just run a for loop t times. We'll take in n and we'll print out f of n. Does this much make sense, guys? This will run 2e5 times, which is O of capital N, because n is 2e5, right? And for each test case, we are printing the answer in O of 1. Does this much make sense? If it does not, please let me know. I'll just show you the solution just in case you're not able to understand. So this function g, what does this do? It takes in a number and it returns the sum of its digits. Okay, how do we remove the sum of its digits? We just run a while loop while x is greater than 0. Okay, let me, if someone didn't know how to compute this, I'll just show it to y'all. Okay, let's say if we have a number 1, 2, 3, x modulo 10 is basically the smallest digit in that number. If this number is x, then x modulo 10 is basically the smallest digit in this number. So what am I going to do? While x is greater than 0, I'm going to take in x modulo 10, which is 3. So I increase my answer by 3 and then I remove this number. How do I remove this number? I just do x divide by equal to 10. After this, since the remaining x, which is now 12, is still greater than 0, I take x modulo 10, which is 2, and then I remove this number. Since it is still greater than 0, I take in x modulo 10 and I remove this number. Now x is 0, so I break. My answer is 3 plus 2 plus 1, which is 6. So this is what this for loop. Ra says, will we discuss f and g? Yes, we will be discussing g. F, no. Right? So,
I have a doubt.
yeah.
Does this pre-computation technique will be included in the runtime or not?
Yes, it will be included in the runtime, right?
Okay, got it. Yeah, got it.
Yeah. So basically, we are just having an array f, and then for all numbers from 1 to 2e5, I'm computing f of I, which is basically f of I minus 1 plus sum of digits of I. And in the end, I'm taking an input of n and printing f of n. Is this much clear, guys? Tell me. If this much is clear, put a yes in the chat. Okay. Someone says he got a TLE for the same solution. Please do send it to me. We'll debug it post the PCD session. What about others? Got it. Okay. Okay. Great. So we have looked at A, we have looked at B, we have looked at C. Now let's look at D. D is a very, very interesting problem. I got stuck on it for quite some time. But the observation here is actually very interesting. Okay. And it shows why pigeonhole principle and all that is important. So what does the problem statement say? Vladislav has non-negative integers, n non-negative integers, and he wants to divide all of them into several groups so that any pair of numbers does not have matching bits among first to 31st bit. Okay. So for an integer k, so on and so forth is given. We must tell how many minimum number of groups you need to make such that this condition is satisfied. So what does the problem statement say? The problem statement says that you are given an integer n and an array of n integers. Okay. You need to divide these numbers into some groups. And what is a special property of a group is that among all elements of a group, okay, in a group, among all elements in the group, let's say there are, for any elements x and y, okay, no two bits of x and y should be same for the first 31 bits. 31 bits. This is what is given. Like if I have a set of numbers in a group, let's say A, B, C, then no two bits, like if I take A, B, then no two bits of A and B should be same. If I take B and C, no two numbers of B and C should be same. And this should hold for the first 31 bits. Basically, since it is given AI smaller than equal to 2 raised to 31, then no two bits for the first 31 bits. Is the problem statement clear, guys? First, tell me this. Is the problem statement clear? Yes. Now, for people who are not able to solve this, their XOR should be 0, not really. No. For people who are not able to solve this, I'm going to give you a magical observation. You can take this as a hint. The observation is that a group cannot have more than two elements. Okay. Now, why am I saying this? You might be wondering, why am I saying that a group cannot have more than two elements? The thing is very, very simple. The idea is that I'm not making a 31 length string. I'm making a let's say 4 length string. Okay. Let's say it was not 31, it was 4. And currently there is a set in which I have put 1011. Okay. Keep in mind that it's a 4 length string, not a 31 length string. Let's say if it was a 31 length string, then it would have just been 0, 0, 0, so on and so forth. Okay. So if I want to put another element in it, it has to be 0, 1, 0, 0. Okay. It has to be this. Otherwise, there will be such a bit where both of the bits are same. And apart from this, I cannot put any other number. If I put let's say you would say that, why are you saying, why can't we put any other number? Let's say it was possible to put another number. If I put a 1 here, then it will conflict with this number. If I put a 0 here, then it will conflict with this number. Similarly, if I put a 1 here, it will conflict with the second number. If I put a 0 here, it will conflict with the first number. So no matter what I do, a number is always going to conflict with one of the two numbers. So that is why a set can at most have two elements. Is this much clear, guys? Tell me, guys. Yes? Yes? Okay. So if this much is clear, let's say I have a number x, okay? I have a number x. What am I going to do? How, like, let's say this is my first element in a set. I just need to check if the second element I want to insert, like which would be possible, is present or not. Okay. And how do I find this? Let's say this x was 0, 1, 0, 0. I am taking bit length 4. Okay. You can solve it for 31 because making 31 zeros would take a lot of time. So what is the other number? The other number is 1, 0, 1, 1. Basically, wherever there is a 0, there should be a 1. And wherever there is a 1, there should be a 0. How do I find this number? I just XOR it with 1, 1, 1, 1. 1 XOR 0 is 1, 1 XOR 0 is 1, 1 XOR 1 is 0, and 1 XOR 0 is 1. So if I just XOR it with this mask of length 4, I will get what is the second element needed in this set. Now, if this second element is present in the in the array, then we just pair it up. Okay. Otherwise, what do? We just say that, okay, there are not, for this element, I am just going to insert a single element and move on. That is more or less the solution. Did you guys understand the solution? Can we use not operator here? I think you would be able to use the not operator here as well. I just am depicting how to solve this using XOR. For people who don't know how to take inverse using XOR, teaching how you could do it using a XOR. So if the idea is clear, my implementation was not the best one, but was pretty decent. Okay. So what am I doing? I am taking input of the array and then I'm maintaining a multi-set. Okay. What does my multi-set hold? My multi-set holds all those elements which haven't been paired yet. Okay. Because once you pair an element with some other element, that set is fixed. You cannot add elements into that. So that set is going to be fixed. So what am I doing? I am iterating through all the numbers. And what is my mask? My mask is int max, because 2 raised to 31 minus 1 is nothing but int max. Okay. So what element do I need to pair this number with? It is nothing but mask XOR I, as I showed you, right? I want to find which element do I pair up with. So I just XOR it with the mask. Now, if this element is present in the multiset, what do? I say that my answer increases my 1. Basically, I have fixed this particular set and then I remove this element from my multiset. Basically, I have fixed this set of 2 elements and then I remove the complementary element from the multiset. Otherwise, what do? I just insert my current element into the multiset saying that, okay, hey, this is open for pairing now. So later when I'm processing the other elements of this array, if I ever find that this element is needed, then I can just pair it up. And in the end, all the remaining elements, after processing all the remaining elements that are there in the multiset, those elements are the elements which will be of a group of size 1 and everything else will be of group size 2. Whenever there is a group of size 2, we have counted it. So in the end, my answer will be answer plus multiset dot size. Is this solution clear to you guys? Like, this is not the most clean solution, but this is just like the problem 2 sum. You could use a map to do this as well. I just used multisets because that was more intuitive to me. Others asks, what is the value of mask? Okay, very good question. So when k was 4, we took 4 ones. Okay. So when k is 31, basically the number of bits is 31, we are going to need 31 ones. Now what is 31 ones? It is 2 raised to 31 minus 1. This is a basic observation. Basically, 1 repeated k times, okay, is nothing but 2 raised to k minus 1. if you wanted to take some examples, when k is equal to 1, 2 raised to 1 minus 1 is 1. When k is equal to 2, 2 raised to 2 minus 1 is 3, and 3 in binary is 1, 1. When k is equal to 3, 2 raised to 3 minus 1 is 7, and 7 is 1, 1, 1 in binary. So you just need 2 raised to 32 minus 2 raised to 31 minus 1, and this just happens to be int max in C++. Is this much clear? Shekhar asks, what is wrong in my approach? Count max of count 0, count ones for all values of 1. Okay, so I'll give you the test case where your solution fails. I also thought this was the solution, but if you take the test case where I'm just taking 3-bit numbers, okay? So it is 110, 101, 011, and 000. So in your case, the answer should be 2, because in this there are 2 ones, 2 0. Here there are 2 ones, 2 0. Here there are 2 ones, 2 0. So answer is 2. But actually the answer is 4, because first you would want these two in separate groups because they have the same bit. Now, if you look at let me just write it, right? 110, 101, 011, 000. Now, if you take the number 000, it does not form a pair with any group, so it has to be one group because each number has a 0. If you look at 011, 011, so it does not pair with this group because the last bit is 1, and it does not pair with this group because the second bit is 1, so this also has to be a single group. And both of these remaining numbers have the first bit 1, so these both have to be a single group. So the answer for this test case is 4 and not 2, which will be in your approach. Is it clear? Great. So we have solved A, B, C, and now D. Now we'll be moving to problem E. So what is problem E? It is a very interesting number theory problem. Okay. So if your math is weak or you want to improve in math, it's a great problem to think about. Vladislav has n cards numbered 1 to n. He wants to lay them down in a row as follows. First, he lays down all the odd numbered cards from smallest to largest. Then he lays down all the numbered cards that are twice an odd number from smallest to largest, and so on and so forth. Okay. Now, what does the problem statement say? The problem statement says that you are given a set of elements which is from 1 to n. Okay. Then what do? You place all the odd numbers. Okay. What are the odd numbers? It is nothing but 1, 3, 5, 7, so on and so forth. Then you place 2 into odd numbers. 2 into the odd number, which is what? 2, 6, 10, 14, so on and so forth. Then you place 4 into the odd number. Okay, which is, or you place 3 into the odd number, which is 3, 9, 15, so on and so forth. Okay, then you do it for 4, 5, right? Now, there are some things that we should notice. Let's write it down. We are given an odd number, okay? Like the base is the odd number, right? Whatever number we are multiplying it with, it is with an odd number. So when you multiply an odd number with an odd number, you get an odd number. And whenever you multiply an odd number with an even number, you get an even number. These are the two facts that are very important for this problem statement. Is this much clear, guys? Whenever you multiply an odd number with an odd number, you get an odd number. And whenever you multiply an odd number with an even number, you get an even number. Does it make sense? Tell me, guys. Put a yes in the chat if it makes sense. Okay. So the thing to notice is that first we are placing all the odd numbers. Then we are placing 2 into odd numbers. So when we'll be placing 3 into odd numbers, these are again just odd numbers itself. So these are going to overlap entirely with this. So this is redundant. There will be no number placed because all numbers that are 3 into odd that are already being placed. I'm not talking anything about even numbers right now. I'm just talking about the odd numbers. Similarly, then we place 4 into odd numbers, and then you see when we place 5 into odd numbers, these are still odd numbers. And since odd numbers have already been placed, these are redundant. So what is the observation here? For every odd I greater than 1, I into odd numbers will never be placed. Okay, is this much clear, guys? Put a yes in the chat if this much is clear. For every odd I that is greater than 1, this I into odd numbers will never be placed because since it is an odd number, odd into odd is odd. So it has already been placed when we were placing the first elements. Put a yes in the chat, guys, if this observation is clear. Yes, no. Okay. If you have a doubt, you can feel free to ask the doubt, right? Okay. So moving on. For every odd I, if I into odd numbers will never be placed. Now we know that odd into I will never be placed. So let's extend this a bit more. We know that 1 into odd numbers is going to be placed. 2 into odd numbers is going to be placed. 3 into odd numbers is not going to be placed. 4 into odd numbers is going to be placed because it's not intersecting. If you look at this, 2 into odd numbers and 4 into odd numbers, these will never ever intersect. Okay, because 2 is the only even prime number. Okay, and since both of these elements are odd, they won't have any into 2 in it. So 2 into odd numbers will always be disjoint into 4 into odd numbers. Basically what I'm saying is 4 into odd numbers can be said as 2 into odd numbers, right? And since these two are not the same, they won't intersect. Now 5 into odd numbers will not be placed. Okay. Now 5 into odd numbers is not going to be placed. What about 6 into odd numbers? 6 into odd numbers can be said to be 2 into 3 into odd numbers. I'm just decomposing them into their prime factors, right? Now 2 into 3 odd numbers. If you look at this, 3 into odd numbers is just an odd number. So what we are basically placing is 2 into odd, a subset of 2 into odd numbers. And since we have already placed 2 into odd numbers, 6 into odd numbers won't be placed. What about 7 into odd numbers? 7 into odd numbers is odd, so this won't be placed. What about 8 into odd numbers? 8 into odd numbers is 2 into 2 into 2 into 2 into odd numbers. these do not intersect with anything, because you cannot, like, here I knew that 3 into odd numbers is just odd numbers. But even if I take this as 4 into odd numbers, it's still 2 into 4 into odd numbers. So it does not really repeat with anything else, right? So this is going to be placed. Is this clear, guys? Tell me. Like, till now, whatever I said, is the idea clear? Like, why something into odd numbers will be placed and why something into odd numbers is not going to be placed. Okay. So what do you deduce? We saw that 1 into odd numbers is going to be placed. 2 into odd numbers is going to be placed. 4 into odd numbers is going to be placed. 8 into odd numbers is going to be placed. So on and so forth. So what is our deduction? Our deduction is that for every power of 2, for every power of 2, let's say it's called P, then P into odd numbers will be placed. Okay. This is the first thing. And second thing to notice is that none of them intersect. None of them intersect with each other. Basically, what I'm trying to say is that if you find out all the elements that are 2 into odd, and let's say you pick out all the numbers that are 8 into odd, none of the elements are going to be same. All of them are going to be independent of each other. These are the basic two observations that we did till now. Is it clear till now, guys? Tell me. We did two observations, that for every power of 2, P into odd number will be placed, and none of them intersect with each other. Now, if this much is clear, all that we have left to do is to count. So we are given n and we are given k. Okay. So first of all, if I know, okay, that the power that is going to be used is P, and the number that was paired up was the ith odd number. Okay. So what is my answer? My answer is just 2 raised to P into 2 into I minus 1. What am I trying to say, guys? If I know that the power of 2 that I'm going to be using, like basically what the kth element is, if the power of 2 that I'm going to be using is P, okay, and it is multiplied with the ith odd number, then my answer is just 2 raised to P into 2i minus 1. Why 2i minus 1? Because the formula for the ith odd number is 2i minus 1. Is this much clear? Like if I tell you for what power we are going to use, and I tell you which odd number is it's going to be, which is multiplied with. So your answer is 2 into P into 2i minus 1. Is this much clear? Tell me, guys. Put a yes in the chat if it is clear. If no, just put a no. Okay. Udit says yes. What about Shaker? Okay. So since this much is clear, like if there is a power of 2P and if it's the ith odd number, then our answer is going to be 2 into P into 2i minus 1. Now, if this formula is clear, our job is to just count. What will we be doing? We will be iterating from P is equal to 0 till P is equal to 30. It is not really necessary. And we are going to store how many elements are placed till now. Okay. Let's say this number is X. Now we are going to place all numbers. This is a for loop. Okay. We are going to place all numbers such that they are 2 raised to p into some odd. Okay. We are iterating from 0. We are going to 30. And when p is equal to something, we are going to place all numbers such that they are of the form 2 raised to p into some odd number. Now, what is the condition? The condition is that 2 is to p into odd should be smaller than equal to n. Now, what does this imply? This means that the odd number should be smaller than equal to n divided by 2 raised to p. Okay. What did we deduce? All the numbers that we are placing should be of 2 raised to p into odd. Now, what is the condition that we need to satisfy? 2 into p into that odd number should be smaller than equal to n. Hence, that odd number should be smaller than equal to n divided by 2 raised to p. Now, if I tell you if I ask you to compute how many numbers are odd in the range 1 to n divided by 2 raised to p. Let's say n divided by 2 raised to p is x. Okay. I'm just giving it a variable name. I ask you how many odds in range 1 to x. What is your answer, guys? Tell me. If I ask you if I give you an integer x and I ask you how many odds are there in the range 1 to x, what is your answer? Exactly. Not x divided by 2. It's going to be x plus 1, the whole integer divided by 2. Or what you could say is TLE division x by 2. Right? Basically, ceil of x by 2 is what is going to be the number of odds in the range 1 to x. Is this much clear? Suman, Shekhar, Udit? Great. So, if there are x by 2 odd numbers such that 2 into p into that odd number is smaller than equal to n, it means that we will be placing x by 2 odd numbers right now. Okay. So we have a variable placed. Okay. So we will be increasing our placed by x divided by 2, ceil of x divided by 2. Now, the first p where placed becomes greater than equal to x. In that case, what do we find out? We just find out which odd number was, k, which odd number was the one which was kth, and then we just print 2 raised to p into whatever that odd number was. Now it is very simple to find which odd number was placed. This can be found easily. Let's say we placed x by 2 numbers right now, and we know that some of these are excess. So how many of these are excess? Placed minus k are number of excess odd elements that we have placed. So if we have placed x by 2 numbers and some of these are excess, then if this is I, then it is the ith odd number that we need. If we take an example, let's say we placed 135 right now, and k was 2. Okay. We placed 3 numbers. We were supposed to place 2. So 3 minus how many are placed right now? 3 minus 2. So here it is 3 minus 1 and this is 2. It means that the second odd number was the one which was placed. Is this much clear, guys? Tell me. If it is not clear, please do let me know. Otherwise, please drop a yes in the chat. Udit says clear. What about Shekhar? About Suman? Great. So, if this much is clear, that is more or less the solution. Let's move on to the solution of this. Solution is very simple. If odd into power is smaller than equal to n, then odd is smaller than equal to n by power. So if k is smaller than equal to the number of odd numbers, then I just print out that odd number. Otherwise, what do? I say that the number of odd numbers, I think this if statement was not necessary, but okay. What do? The current number of numbers that I have placed is n plus 1 by 2, and the current power I am on is 2, which is basically 2 raised to 1. So while power is smaller than equal to n, the numbers that I can place is number divided by that power. So how many odd numbers are there? Number plus 1 by 2. Now, if sum becomes greater than equal to k, then my index is nothing but number pos plus 1 divided by 2, which is the number of elements I placed right now, minus the number of excess elements. So what do I print? I print the ith odd number into the power, and then I break. Otherwise, I just multiply the current power by 2, because if it's 2 raised to 1, which is 2. Now, if I want to get to 2 raised to 2, it is 4. So I just multiply the current power by 2. I hope this much is clear. Please do let me know if you have doubts in this implementation. Okay. Since I see that there are no doubts, we'll be moving on to the final problem of this problem set. Vlad and trouble in MIT. This is a very standard problem, okay? And it requires a basic understanding of DP on trees, right? So what does the problem statement say? That a student wants to party. There are some students, okay? And they are connected in a tree format. Let me just draw the sample test case, okay? So let's say 1, then it's connected to 2, and this is connected to 3. A student can be of 3 types, either P, either S, or either C. P means he likes to party, okay? S means he likes to stay silent, and C means he can be any, he doesn't really care, okay? C means doesn't care. What do you basically want to do is, you want to place some walls between the rooms, right? Basically on an edge, you can place a wall such that if there is a P here, okay, and there is a S here, then they should be between a wall, because party people and silent people don't like to stay together. So you need to place a wall between them. What does the problem ask? Tell me the minimum number of walls you need to place. Okay, this is what the problem statement asks. Now, the first thing that you might ask, yes, Raj says it was difficult. Yes, it was a difficult div too. The first thing that you need to realize is that when there are 3 kinds of people, one likes to party, one likes to stay silent, and the other one doesn't care. Now, this person who doesn't care, basically, what you have is two choices. Either he can be a party person or he can be a silent person. Okay. And whenever you are on some particular edge where it is either of this type or this type, basically you have a choice that every person of type C can either be a party person or silent person. Let's say you fix that and then you are going to the other edge. If the current person is a party person and the edge you are traversing to, the other person is a silent person, then you are forced to build a wall here. Similarly, if the current person is a silent person and the node that you are going to right now, or basically the any of the adjacent node is a party person, then you have to build a wall here. Is this much clear, guys? Like if there is an edge connecting a type P person to a type S person, then you are forced to build a wall between them. Is this clear? Put a yes in the chat if it is clear. Okay. Now, if this much is clear, what choices do we have? On every node, okay, we have two choices. Like if it's a P or S, then okay, we have no choices. But if it's a C, we have two choices. Either to fix it as a P type of person or to fix it as a S type of person. Okay. This is what our choices are. Now that our choices are clear, right? We have some choices right now. If we were, see, we have two choices and we have n nodes. So basically, if we would write a brute force, this would be 2 raised to n operations, basically too much. So we basically need to memorize this. Let's say P is denoted as 1 and S is denoted as 0. You have a choice that each node can be 1 or 0. Apart from this, there is a small edge case that you need to consider. What is this edge case? Let's say you are on type C right now and you are going to another node of type C. So the idea here is that if you fix it as P or you fix it as S and you are going to C, you don't really know that will I be building an edge here or will I not be building an edge here? It is only after you have fixed this C as well is when you will know that would I need to build an edge here or not need to build an edge here. Okay. So what did we learn till now? First thing, we have two choices. We have two choices. Fix every C type to either P or S. Apart from that, when you are going from C to C, you are not sure. You are not sure whether you are building a wall or not. Okay. So since you are not sure in this particular case, like this we can do easily. How do we handle this? It is very simple. Let's say we are on a tree and we are traversing. For every node, we just store what was the color of its parent or what type was its parent. Basically, what does dp of I comma j represent? It represents that we are on node I. Basically, this is node I, and the color of its parent was j. Basically, if the color is 0, it means that it was silent, and if it was 1, it means that it was a party kind of animal, right? Now, when you are on a particular node, you have two choices, either to fix it as a p type or a s type. If you are fixing it as a s type, you increase the answer by number of adjacent of s type, and if you fix the current node as a s type, then you increase your answer by number of adjacent of p type. Is this much clear, guys? Tell me. Shaker, is this much clear? Okay. So if this much is clear, I would like to explain the other part of the solution to you all via the code, right? Because it is important to understand DP on trees. So I'm maintaining one based indexing here. So that is why after taking the string, I am just appending a random character at the start of the string, right? So what are we basically going to do here is that we took a string, we are taking input, and then we are appending a character to its start. After this, we are iterating from 2 to n. We are taking an integer x, basically what was its parent. We are pushing it back into the number which was here, right? After this, we are maintaining a DP table. DP of I comma j basically represents that we are at node, current node, and its parent color was 1. Now, if DP of node comma parent color is not equal to -1, then we return DP of node comma parent color. Otherwise, we have two choices, either to make the current node of S type or to make the current node of P type. Please keep in mind, when we are making something of S type, we are denoting it by 0. When we are making something of P type, we are denoting it by 1. So if node S is not equal to P, this means that either it's S or it's C. So it means that we can make this node of S type. You can't change the type of node of S and P type, right? So if it's not P, we can make it of S type. So make S initially will be 0. If no, it will be 1. When will it be 1? If my current node is C and its parent color is 1. Why am I doing this? Because when I am traversing like this, and the node type here was C, and I fixed it to, let's say, P here. When I was here, I couldn't really fix that will I be building an edge here or not. But when I have come here and I've fixed it to an S type, I can say that, okay, making an edge here is important. Okay. And that is why I increase 1 to my answer. So this is what I'm doing. If the current node type was a C type and the parent color was P, basically 1, I set my answer to 1. Otherwise, I set my answer to 0. Then I just iterate over all the adjacent elements and I increase my answer by Si is equal to P. Basically, if the adjacent node is of type P, I increase my answer by 1. And then I also increase my answer by what is the answer when I go to that particular node for the subtree of that node. Let me explain it to you via a diagram. Let's say I have a tree, okay? Basically, if I have already computed the answer for this much, I am only fixing this and checking, do I need to make an edge wall here or no? And then I am just adding the answer of these subtrees. This is basically the idea of DP on trees. Now, similarly, you do the same when you want to make the current node P. Okay. So make P is just S node is equal to C and parent call is 0. For auto I in adjacency node, make P plus equal to SI is equal to S and DFS 1, I, 1, and return node parent color is minimum of make S, make P. Basically, you had two choices, either to make it S or to make it P. So DP of node parent color is minimum of those two choices. And in the end, you just print minimum of, like this is just for formality because the first node that you choose doesn't really have a parent. So calling DFS of 1, 0 and DFS of 1, 1, whatever gives me the minimum answer is going to be my answer. Is this much clear, guys? Is this much clear, Shekhar? This much clear, Udit? How we could solve problem G using DP on trees? Were you able to solve this problem during contest? Did you understand it right now? I'm glad that you could understand this. Thanks a lot for watching. I hope I was able to add some value in your life. Thank you. Bye bye.